Thank you for coming. So today we're going to be talking a little bit about SeedXOR and secret splitting. And the goal of this is to maybe give you, maybe not someone who's very technically knows how to use a computer, but someone who maybe is a little bit less confident using a computer, showing how you can do it, you can create a good backup and a secure backup of your Bitcoin seed without mostly not using a computer. So, and yeah, let's just get started. So, first of all, who can give some answers for this? What is a Bitcoin wallet? Yeah?
A piece of software that does the Bitcoin stuff. The sending and receiving pretty much by Bitcoin stuff?
Yeah, yeah. So this is will just kind of set a frame to make sure that we're all on the same page of what it is and as we move forward. So for what I've written here, yeah, software that facilitates the creation and the broadcasting of transactions for its users. Typically, it will connect to a Bitcoin node. If you're using one from a company like Moon or Phoenix, then it probably will connect to their node. Some of them are configurable. You can make it connect to your own node. And yeah, it connects to them to get details of incoming and outgoing transactions, and also the final balance. It allows you to go and have a look and, oh look, this is what I have. And it may interact with signing devices or act as its own signing device. So some wallets, they let you create the wallet on your phone, and you just sort of let it do the seed generation. You keep the seed on the phone. If you want a more secure setup, you might generate the seed on a hardware wallet, something, or you might use a device like a seed signer to create a new 24 words or 12 words. And then there's a bit of setup, but you can create a file that will talk with the wallet and allow you to see your transactions without having the ability to sign it on the phone. You have to work with the two devices. So the thing we're going to be focusing on here is the private key. And so this isn't really going to be talking about how do you create a wallet or anything like that, because this is more about creating a seed and then being able to back it up securely and make sure that it's. I think what a lot of people worry about is this like one big password, and what if you forget it? What if you lose it? What if somebody takes it? Right? So let's just, first of all, I'm getting ahead of myself. So private key, it's a randomly picked large number, and it's 256 bits long. And just to give a feel of what a 256-bit long number is, I thought I'd just show this cool little video by, I forget his name, One Brown.
Now, this is a number so far removed from anything that we ever deal with that it can be hard to appreciate its size. But let's give it a try. 2 to the 256 is the same as 2 to the 32 multiplied by itself 8 times. Now, what's nice about that split is that 2 to the 32 is 4 billion, which is at least a number we can think about, right? It's the kind of thing you might see in a headline. So all we need to do is appreciate what multiplying 4 billion times itself 8 successive times really feels like. As many of you know, the GPU on your computer can let you run a whole bunch of computations in parallel incredibly quickly. So if you were to specially program a GPU to run a cryptographic hash function over and over, a really good one might be able to do a little less than 1 billion hashes per second. And let's say that you just take a bunch of those and cram your computer full of extra GPUs so that your computer can run 4 billion hashes per second. So the first 4 billion here is going to represent the number of hashes per second per computer. Now, picture 4 billion of these GPU-packed computers. For comparison, even though Google does not at all make their number of servers public, estimates have it somewhere in the single-digit millions. In reality, most of those servers are going to be much less powerful than our imagined GPU-packed machine. But let's say that Google replaced all of its millions of servers with a machine like this, then 4 billion machines would mean about 1,000 copies of this souped-up Google. Let's call that 1 kilogoogle worth of computing power. There's about 7.3 billion people on Earth. So next, imagine giving a little over half of every individual on Earth their own personal kilogoogle. Now, imagine 4 billion copies of this Earth. For comparison, the Milky Way has somewhere between 100 and 400 billion stars. We don't really know, but the estimates tend to be in that range. So this would be akin to a full 1% of every star in the galaxy having a copy of Earth, where half the people on that Earth have their own personal kilogoogle. Next, try to imagine 4 billion copies of the Milky Way. And we're going to call this your gigagalactic supercomputer, running about 2 to the 160 guesses every second. Now, 4 billion seconds, that's about 126.8 years. 4 billion of those, well, that's 507 billion years, which is about 37 times the age of the universe. So even if you were to have your GPU-packed kilogoogle per person multiplanetary gigagalactic computer guessing numbers for 37 times the age of the universe, you would still only have a 1 in 4 billion chance of finding the correct guess. By the way,
So
the state of Bitcoin hashing these days is that
that's not as relevant. Oops. Bring that back. Really? Oh, there you go. Cool. So the purpose of showing that video was just to give you make it really solid, settled that this is a key, a password that you're going to generate, which no one else is going to have. Like, that's how secure a private key is. And even though it's just a random number that you're going to pick in a random fashion. Because it's going to be, it's kind of sometimes hard to fathom. Like, I'm going to roll the dice a few times, I'm going to write a few numbers, and are you sure no one else can get the same number as me? Yes. I wanted to touch a little bit about XPRIV, or extended private key. When you have a wallet, you have one backup, and it's like a seed, like 12 words, 24 words. And that represents one of these numbers. And we'll talk about exactly how those words represent those numbers in a minute. But that isn't the private key for a specific address. That's a private key. It's called an extended private key because from that, then your wallet will generate more private keys, and those are the private keys for your actual addresses. So with one key, you can have effectively, practically an infinite number of addresses to send Bitcoin to. So let's talk about numbers. There's different ways to represent a number. So I've taken this number, 1,223,061, and I've formatted it in different formats. So the second example here is base 2, which just is a string of zeros and ones, but that's another way to represent the exact same number. And the last one here is hexadecimal, base 16. And what you'll see is it has numbers, but it also has letters. Every digit ranges from 1 to 9 to A, B, C, D, E, F. So the 16 potential values per unit on the number. And we're going to be using hexadecimal in our little workshop. So I found this, well, actually this was presented by Alex in the previous talk, this website, where you can, if you go to this website, and maybe the link will be shared out, but you can kind of click and change the numbers here, and it will show you from binary what that same number is in decimal, and then what it is as a word. And I'm just going to show real quick. What I brought is a big list of words, and in here there is 2,048 words, and each one is represented by a number. It's not, in the sheet that I've given to you, it's not actually referencing by binary or decimal, it's referencing by base 16, hexadecimal numbers. So all of those ones and zeros, all the way up until number 24, excluding the yellow part, is your private key. It's actually your private key. This is 256 bits. It's a 256-bit long number. The last part in yellow is what we call a checksum, and it's used to make sure that when you finally get your words, when you're typing it into a wallet, the wallet can know through some mathematics, it can check the last word and verify that the other, like there's been no mistakes in the rest of your key. We're not going to focus too much on that, but effectively your private key, the actual key part that's used for signing, it stops right there. So I wanted to give a feeling of XOR and like how you can generate a number which stays, like when we're doing splitting of our seeds, what we're going to be doing is we're going to be taking, like, typically you take 24 words, or you take the big 256-bit number, and you take another 256-bit number, and you would do this operation with them, and you would get this other number. And one of the things that's really interesting about it is you end up with two pieces of information, two parts. And when you're backing up, what this is really useful for is you can have one part, for example, on a seed phrase or in your pocket, and another one somewhere completely different, at home. It could be on the internet even. And why I say on the internet is because with only one part, you're nowhere closer to getting to the final answer. And the way that I thought I'd illustrate this is to kind of, well, so what I want to do is I want to choose three people and just sort of call out a number. So can you call out a number between 0 and 9? 3. Okay. So right now this is our first part of the secret. Can you call out another number? 3. Okay. Okay, cool. 6. All right, another number? 9. Okay, cool. So when we try to add 9 to 6, what we're actually going to do is we're going to follow this wheel. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And we got the number 5. So no matter what numbers you add, you're always going to fit in within this range of numbers. But also, let's pretend that the two numbers were 6 and 6 and 9, was it? Just by knowing 9, you have no idea that the next number is going to give you the number that we ended up with just a second ago, and vice versa. Like either number, you're not really going to know. You're not going to, like, you can't, for example, when you add two numbers like 2 and 2, and you say the number's going to be within 10, you might go, well, since the first number's 2, it's not going to be 0, 1, 2, maybe it's going to be anywhere between 3 to 9. But because we do this loop thing, you don't know that, you haven't reduced the range of numbers that your private key is going to be within. So let's talk a little bit about secret splitting. First of all, it's not the same as multisig. Multisig is, I'd say, actually a better setup, but it is more complicated. It's more secure, if I'll say, but it is more complicated. And so for a typical person who just wants to get started in Bitcoin, I don't think it's necessarily the best thing to learn first. But secret splitting gives you this ability to have multiple secrets that are by themselves, pretty secure. They're both 256-bit long passwords. They're not just like, this is my password, 1, 2, 3. So it allows for creating a robust backup solution. You can actually create more than 2 as well. You can create 3, 4 parts of a secret. And in my opinion, secret splitting is actually better for inheritance. And the reason is because when you're saying, okay, this wallet is going to be passed down to, say, you, we're not going to, I'm going to need to teach you or give you instructions on how are you going to restore the wallet. If those instructions are like, well, get one hardware wallet and then get this other hardware wallet and then put in the private key to this one and scan it and so on, like it's a lot more extra steps. So with secret splitting, you can do most of the maths and stuff on paper, and when you finally got your private key, you just load it into a wallet and you can sweep the funds, you can use it. So in comparison, multi-sig typically will require 2 or more signing devices. I put an asterisk on there because there is this cool little device called the seed signer. I haven't got a case for it, so that's why it looks all dangly and the little camera module's dangling off. But with one of these devices, it doesn't actually store the private key on the device. And so if you did have multiple private keys, this thing could take typically you would store the private key as a QR code with one of these devices. And you would take a picture of it, you would be able to scan for the first private key, then you go to the second location with this device and you could scan. So you don't need multiple signing devices in that case. But for most wallets like Coldcard or Trezor or whatever, you're going to need more than one signing device typically. One thing that's true is you're always going to need to sign twice. So you're going to have to take one of these devices and you're going to have to do 2 operations on these things. And typically you want to keep the keys in different locations, so it can be time consuming. You have to, I'd say personally, it's a little bit more scary for someone who isn't familiar with these devices or doesn't want to play with technology too much. And then finally, future wallet software is hard to describe. So today you have Blue Wallet, you have Moon, and so on. Maybe in the future, all of those have gone away and all the Bitcoin wallets in the future are completely different. If that's true, then if you create instructions on how to set up a multi-sig and everything, it could be that it's difficult to follow those instructions by the time, yeah.
Couldn't this exact same argument also be said for the SeedXOR though? For the seed split, sorry. Because it's like, well, what if no one will know how to use this also in the future and because then we found or something?
Fair, because like if you look at it, we're actually maybe even moving on from just having 24 words to having, is it script? There's a script kind of backup thing that we're looking at now, right? Where you don't just encode the 24 words, but you also encode like what type of wallet is it? Is it a script hash wallet?
I see what you mean.
Yeah.
You mean the wallet descriptor, I think is what they're called.
Yeah, wallet descriptors. So that might actually change how we do backups in the future anyway. But the private key to seed words to all that stuff is pretty standard. And getting to that point where you have this standard, everything else can be printed out as I printed out already. And so when you give inheritance instructions, it's follow these instructions, do these steps, and then you'll have this thing which is standard and it's not going to go away. But when it comes to signing multi-sig, I don't know that there isn't really like a standard way to do multi-sig, although chances are that whatever is available today, or there is going to be some instructions that's going to be legible in the future, probably.
Right. So it's kind of like the same way we have legacy addresses now, and well, they're still supported, but kind of no one uses. Maybe something like that with multi-sig, you're saying? Maybe. Maybe that was a bad example.
Yeah. Okay, so XOR, let's talk a little bit about that. So typically what you would have is 2 sets of 24 words, and together they reveal a secret number. I almost feel like the number wheel example should have been a little bit further forward, but hey. When you have these two secrets, the order is unimportant. So your seed word backups, you can apply them with the first one first and the second one you can do the operation, or you could do it the other way around. If you have 3, again, still, the order doesn't matter. You can do the last 2 and then XOR the first one as the second step. It will give you the same answer every time, this operation. But without every key, you're no closer to that final number. And so, as we kind of showed with the number wheel, even if you add up the first 2 private keys, you're not going to be any closer to knowing what that final answer is going to be. And one thing that's really interesting is you can create a distinct set of keys, create distinct sets for the same key. So in the same way that 1 plus 5 is 6, and so is 4 plus 2, you can do the same thing here, and I think that's kind of unique, and I've had a little bit of a think, like you could, for example, have a backup for yourself of your own wallet, which uses 2 sets of seed words, and then you can have an inheritance setup, which uses 2 completely different seed words. And the benefit of that would be that if the setup for the inheritance gets compromised in any way, your setup is completely unrelated.
Also,
So.
the wife doesn't get the money though in this situation. That's the bonus.
Yeah. Well, if your wife is the inheritor, she'll get it eventually.
Well, she get the inheritance, but not your wallet. That's what I was trying to say.
Well, no, but these seeds are for the same wallet.
Oh, for the same.
For the same wallet, yeah. But the idea is like the inheritance setup might be you give one of the words to the lawyer, and the other one you give them directly. But let's say that your wife is the inheritor and she's not very good with computers. She decided to put it on the internet and she leaked it. It's gone. Everyone knows it now. Well, as long as no one knows to attack the lawyer, your funds are going to be relatively safe. But at least no one's going to be able to break into your house and find one of your keys and then go, right, I've got 2 pieces, let me put them together, because they don't add together.
Yeah, sorry, I misunderstood. I see what you were trying to say, like you can even use them separate. I mean, you said it, but I didn't got it yet, sorry.
Yeah. And every part and every combination actually creates a valid private key. So this is really interesting as well, because if I have like 3 parts, maybe you find 2 of them and you go, right, got it, put them together, there's nothing there. You don't know whether it's 3, 2, 4. And also, I could put a little bit of Bitcoin in one of the combinations and you go, right, I found it, and you'll stop looking. Whereas the full amount of my Bitcoin is somewhere else, So you can think creatively with these sort of tools. And finally, yeah, like I said, partial combinations can contain Bitcoin as decoys to stop somebody from looking further. So we're going to do a little workshop. So what we're going to be doing is we're going to be rolling dice. And as we roll the dice, we're going to write down pairs. So like I got a 6 and a 6.
So 2 dice.
2 dice, yeah.
Well, actually, it doesn't matter. You can roll.
You can do it 1 at a time. You could do 4 at a time if you wanted to. And they've got plenty of dice actually. And then the next thing we're going to do is we're going to use this little guy here, the XOR map, which is the one on the leftmost, which is a lookup table. And you're going to say, okay, my first roll is you're going to take it from the X coordinate across, and then your second dice you're going to read down, and you're going to get a letter or a number. You're going to put that into, underneath the rolls, you're going to put that into the hex digit row on the sheet. We're actually only going to go as far as 3 of these, because if we went throughout to try to do the whole 24, then it would take a long time.
So for one word, we need like how many rows? 3 pretty much.
We need 3 letters per word.
Yeah.
It's going to be a total of 2, 4, 6 rolls per word. But when we do the first digit of every word, it's going to be in the range of 0 to 7. So if you end up looking at the table and you get like an F, just look at the most significant digit converter and you'll see that it's...
Why is it going to be 0 to 7?
Because the range of words is 2048.
Correct, yeah.
But the range of a 3-digit hexadecimal number is double that.
Oh, I see. Okay, I see that.
Yeah.
Okay, gotcha.
Why do we need to XOR?
Maybe I labeled that wrong. It's not the XOR map. Oh wait, not this one. You're right. There is a table here which is 2 6-sided dice to hexadecimal. That's the table you're going to be using.
The XOR comes later.
The XOR comes later for sure, yeah.
That's why in the middle of the block.
Oh shit. Is it cut off?
Yeah.
So first we roll the dices and then we get them converted to hex and then we sort them. That's what I'm trying to say.
Yes, exactly.
Okay.
But you can take the bottom tile and it's gonna be the same thing.
So the idea here is to give you guys a little bit of experience. Like it's hard to explain, but I think once you've done it a couple times, you'll get the feel of it and you'll go, okay, I can do this. This is not that difficult. And that's the hope of this talk. So another thing to note is that the six-sided dice table, it looks symmetrical when you look at the first few numbers, but when you go to the last bit, if you go look at the 5 by 6 and 6 by 5 areas, you'll see that they're not symmetric. You've got a 6 and a D. So the order, like knowing the order in which you're reading the dice and then getting your answer is important. You could, if you just get a 6 and a 5, decide to roll again, right? Just ignore that and roll again if you want to. And there is a bias in this table because this didn't give you a perfect number of values to map. But I've actually did a little bit of maths, and I worked out effectively with this method, you're going to get 254 bits of entropy, which is still ridiculous. Ridiculously.
So the reason we're using hexadecimals and not binary is just so we do less rolls, right? That's the only advantage.
Correct, because if you want to do it with binary, you have to kind of do coin flips and ones and zeros and a six-sided dice is because those are the most common dice. If you have an eight-sided dice, there's actually a table here which shows how to do it with an eight-sided dice. That will be completely fair, and that will be 256 bits of entropy, less complications. Okay, and then the final thing is we're going to be doing XOR last. And so got some pictures here of like when I did this my first time. And you see, so I've written like numbers here, 4, 3, 3, 3, 3, 5, and then next to it you can see BAC, which were the relevant letters. Oh. Then I put them into this little table here, and you can see getting this far took about 6 minutes for me. Then I did the whole thing again and created another set of hexadecimal words, and that took about 10 minutes extra. Oh, let's not go down. Okay, down. And in total, this process for 24 words, 2 sets of 24 word seeds, it took me about 40 minutes. And this was the first time I'd done it, and I was just documenting. When we get to the last word, this is a very dark picture, unfortunately. There's going to be there will be a little bit of a, this is the checksum word. There's a little bit of complication, and I'll explain that after this. So let's go ahead. 2 rolls is going to be 1 hexadecimal letter. 3 hexadecimal letters is going to be 1 word, and we're going to do 6 words. So that's a total of 36 rolls. All right. So what do we do with the parts? So one thing that we've done here is we've created the final 3 words. What we didn't do is look up the 2 intermediate codes and get their words, but we can do that too. And what we would then end up with is 3 sets of 3 words from just this little exercise that we did. And one of them you would choose to be your private key, and the other 2 you would choose to be your backup keys. The private key, you want to make sure that there is no record of it anywhere except for maybe in your wallet or in your hardware wallet, right? And the other 2 are what you're going to back up. You could keep 1, for example. So I don't know if you guys have seen, you get these pieces of steel and you can stamp them. That's what a bunch of people are recommending. You could just put it on a piece of paper, laminate it or something, as long as you, yeah?
The pieces of steel, they actually do binary, they don't do hex, right? Are there any with hex?
No, they store words, so you hammer in the words.
Yeah, but is it like 1 bit? When we're doing a hammering, isn't that 1 bit pretty much?
It depends on the product you buy, right? Some of them you hammer in dots, some of them you hammer in letters.
Oh, I see.
4 words, yeah.
I think you only store the first 3 letters of the word.
The first 4?
4.
Yeah.
First 4 letters.
4 letters, yeah. So
That's regardless of any backup, that's just because of bit 39, yes.
What I found was kind of convenient with this is you could take 1 and you could put it, say, on the steel backup, and you can keep it really secure at home. You could even make another copy of it and keep 1 on your person. So if the one at home gets stolen by somebody, you still have a copy of for yourself, and you've got a small one that you keep in your wallet or you keep in somewhere on your person. Or if you get robbed, then there's still 1 at home, right? And it's okay if it gets stolen because they haven't got all the keys. And you keep the other one online, maybe OneDrive or Google Cloud or something like that with backed up with password, maybe two-factor authentication set up, or whatever it is that is appropriate for you. But effectively, somebody who's going to burgle you or attack you is most likely not going to be able to also attack your online security. And vice versa, somebody who's going to attack you remotely is not very, like, even if it was someone who calls you and is trying to phish you, it's like, yeah, please give us access to your OneCloud address so we can get rid of this virus for you. And then they find the words. They've only found half this words. And yeah.
Yeah, but then you lower the possibility to lose it, one or the other as well.
So when you store something online, it's very difficult to lose, for sure. And then, so for this, you've still got...
Forget what it is online.
Yeah, so obviously some thought needs to be put into it, but you can also put it in multiple locations. I think that you can be a little bit more liberal with your, as long as one's online and one's not online, I think you can be pretty liberal about, where it goes. You don't want it to be completely public. Don't put it on, GitHub where everyone can see it, but, you put it behind some sort of account. Maybe you can even just store it in your email address if you want to. That's one. And then the other one, you have to make it physical. So you store it on a steel plate or a laminated piece of paper or something like that. And you can create multiple of those too. You can be liberal about that too, because if that gets stolen, you need to make sure that if it gets stolen or you lose it, you've at least got somewhere to look for it somewhere else. So you want backups, but you don't have to worry about, oh, it's gone, therefore now I've lost all my funds. Like, the other person is not going to find your Bitcoin from that. They're not going to be any closer to getting to your Bitcoins either from it. If you are worried, then the moment you realize that one of the pieces have been stolen or compromised or lost, you can take that as an opportunity to go and create a new setup and maybe do that in your leisure or as quickly as you can. Ideally, don't wait 10 years.
Sorry, to check. So basically, each piece is an independent seed you could use if you wanted to.
Yes.
So they're less precious now because unless you put something in it, you just need two of the pieces from somewhere, so you can keep loaded copies all over the place. And as long as you can get to two of them, then you can get to your coins, but you don't need to defend each piece quite so harshly.
Exactly. So the whole point of this, yeah, exactly. The whole point, it gives you that similar sort of feeling of multi-sig in that, I don't have to be so pressured about one of them. But yeah, what it gives you is a lot of people are like, well, I've got this digital thing, it's information. If I lose it or somebody sees it, it's not like a piece of jewelry, like they can see it, but if they take it, then it's gone. But if they see it, they haven't taken it. Maybe a key, if they see your key, they can make a print of your key, a house key or something. So it's a bit like that, but it's only half of the key. So you don't have to worry about somebody seeing it or copying it as much as if you just had the one seed word backup, because that's pretty, yeah, you get a bit of anxiety with one key, I think. So it just tries to relieve that. So yeah, one online, one on a safe place at home, have duplicates of the physical key for sure. And then you can also create more keys if you wanted to, and XOR them and find out the result and put maybe a few sats in there as decoys.
Sorry, Dave, this is a very basic newbie question. You're going to tell me this is very different from me splitting my 24 words
Yes.
and keeping 12 somewhere else.
Absolutely. Absolutely. If you take your 24 words and turn it into 12 each, what you effectively have done is, do you remember the number wheel example that I gave where your two numbers, when you add them together, it kind of goes around in a circle? What you've effectively done is taken a number that is, say, between 0 and 10, and you've said, right, here's a number between 0 and 5, and here's another number between 0 and 5. Once I've taken one of your keys, I know now that I only have to search the other half of the spectrum of the keys. So if you think, okay, 12 keys is pretty good security, you could technically split it. It's, you can do it, but it's not recommended. This is absolutely the wrong way to split secrets. If you have a 12 word, please don't split it into two sets of 6 words, because somebody who has 6 words, they can use a computer and brute force the other 6 words. It might take a while, but they can do that. But what's really interesting about this is that you've got 2 sets of seeds, 2 sets of words, which are just as secure as the final answer as each other. There's zero loss in security through this method. So that's why I think it's really interesting. All right, so we had a question about the last word. So if you recall, the last word is a little bit different. And actually, if you look on your sheets, on the 24th word, you'll see 2 X's. And the reason for that is because you can't do this exact same method to get the last word, not for a valid seed word. And that's because calculating that last word requires a computer. You actually have to do some SHA-256 hash algorithm stuff, which actually requires a computer for a valid word. So what are your options for generating that last word? You'll see that there is still space for 1 letter in that last word. That's important because that is your private key. It's the last 2 letters that will be the checksum of your last word. And if you were to type in your seed words into a cold card, when you get to that 24th word, it will show you a list of potential last words that you can choose from. Let's say your last letter was A, and then only one of those words that it offers you is going to be in this sheet in the range of, well, maybe not 8, let's say it was 3. Only one of those letters is going to be in the range of 3. So it might offer you, for example, alert, oxygen, and host. Well, you'll know that because your last word needs to begin with the 3, it can only be host, because host here is 370, whereas alert, I've lost alert. Alert is 031, which is, 0 is that one's first letter. So you can use a cold card, which is a hardware wallet, or another hardware wallet potentially. A device like this, a seed signer, will allow you to do the same thing. You just type in the words. This is a little little gadget that I bought. Cost me, you can get it for about 50 quid, all the parts and put it together. If you like tinkering, it's a really cool project. And yeah, using this, you can turn it on and you get the option to create a new seed word. It will give you the options for the last few words. One thing I was trying to figure out, I've made a little Python script and I was playing around, where you just type in you would write in the letters for your 24 words up until that very last letter, and it would then tell you the output of the last 2 letters. And because it's a small script, and I tried to make it as readable as possible so anyone could look at it and know it's not, maybe even somebody who doesn't know that much about programming could maybe follow the code. PyPico, I found out you can buy these for about 5 quid. Pretty. So it's like a smaller version, it's a smaller one of these, smaller Raspberry Pi. But it also means that it doesn't run a full operating system. It doesn't run Windows. It just runs Python.
All right, so it's bare metal. You run bare metal.
Yeah, and what's good about that is it doesn't have Wi-Fi. I mean, this doesn't have Wi-Fi either, but you can get these with Wi-Fi as well. So. And just to be clear, the reason why you want to avoid something with Wi-Fi, if you can, is because if you can't trust your computer or the software, like if you're running on Windows and you don't know whether it's compromised or not, then you don't know that if while you're doing your work, there is a piece of software looking at what you're doing and then broadcasting that to somebody who, might notice what you're doing, understand what you're doing, and go, that person there generating seed words, I'll just wait for some Bitcoin to get there and then I'll take it. But if you don't have a computer or you don't want to use a computer, I think a valid thing you could do is just fake it. Take your last word, make sure that the first letter, you choose a word from this document. Just make sure that it starts with the letter that you've got that you've written down. And if somebody sees it, they're not going to know until they try to type it into a computer that it's not a real word.
Sorry, I don't understand. You mean like, if I'm doing this the first time and I'm trying to generate this, I should write down I should try to figure out my 2404, because if I'm gonna import it somewhere to send some money or something, no, I need to make sure I'm sending it to the right seed. So what?
Yeah. So what we've done here is actually we've gone from complete scratch. We've just created 2 private keys, and then we've generated the third. One thing you could do, for example, if you've created a wallet with a mobile wallet like Moon or Blue Wallet or something, and it says backup the seed word, I think this is a really cool way to basically create a better backup than just what they tell you to write down. So in that case, one of that seed word is going to have a valid 24th word. It just says you write that down in the worksheet, and then you work backwards. You take from the word, you turn it into the hexadecimal. Then you can roll the dice and create another hexadecimal, and you'll get a final answer. You take the 2 pieces the one that you rolled in.
The second one I just used with my dice, I still need to figure out the 24th word, right? Because that one doesn't have the 24th word.
Correct. So if you don't generate the correct 24th word, it's not going to work perfectly as a decoy. Like somebody's going to type that in and go, oh well, this is clearly not a valid seed word. And maybe they're not going to stop looking for other parts because they know.
I understand. I just feel that the faking it thing, I can't imagine a situation where that makes sense. Like, I have to do that 24 word because the reason is there is so I don't, send mine to a messed up seed or something where I mess it up when I import it somewhere. So I just don't think it makes sense. Or maybe I'm missing something.
Well, if you take 24 words, like let's say right, one of them is a SeedXOR backup. It's one of 2. And that last word isn't a valid 24th word, but if you look it up in the table, the first letter you get is the right first letter that you expect to get. It will work.
I understand that wouldn't be a problem. I just don't think it's good advice. That's what I'm trying to say. The risk part, fake it part, sorry.
Okay.
So.
Yeah, I mean, so for somebody who isn't comfortable with using computers to do this and is really scared about the Wi-Fi stuff and all that, I think it's an option. I think it's there.
This is the last thing I'm gonna put back with, but it's like if someone isn't like tech savvy, I also think they may be even more prone to making an error when using these things or importing it then. So they probably need to check some more. But anyway, we could go on forever on this. So yeah.
So yeah, the last word. So also, if you look at the last sheet, if you look at the sheet on the 24th word, the last box is actually double the size. So you can see like it's got a line here. So another thing what you can do before you've worked out what that 24th word is you can write the first word and the last word that it could possibly be, and then that will help you, when you're looking up what that 24th word would be. So for example, so this is how you'd look at it. So you would have this number 3 as your last letter, and you'd know that there has to be 2 following hexadecimal characters following, and that's going to be your checksum. That wasn't the point I was making with this slide. That's fine. But yeah, so if 3 was your last word, then you might put gas as your first word, which is 300, and lend as your last word, 3FF. And then when you go and use your cold card or some other device to figure out what is the last word, when it shows you the options of list of words that it could potentially be, it's an alphabetically sorted list of words. You just need to find the word that is between those 2 words. And there will only be one.
Don't you have like 96 possible word for each one? Isn't that like 2 to the 8th?
When it comes to 24 words,
yes,
you will get...
Oh, it's actually even more than that.
No. For the 24th word, because it's only... You get 16. You get 16 potential last words for the last word on a 24 word seed.
But don't you have 8? Isn't the last 8 bits the checksum?
Yes.
So isn't that 2 to the power of 8?
Yes, but
Oh, so you're saying words.
there's only one. There's yeah. The check.
When I said it's bits, it's not words. Yes, correct.
Yeah. Like your device, when you do 24 words, your device will show you 16 potential words that you can choose from. When it's 12, I think they'll show you more, but it's still the same thing applies. And actually, I've just documented here. So when you do SeedXOR with 12 words, if you decide to do not 24 words but 12, then actually this sheet should change because it's only the last character that is your checksum. You will end with, you will have written 3A as part of your dice rolls as the last word. And so yeah, then you will get a lot more. What is that? 16 times 16?
Yeah, 64.
64.
No, 96.
96?
Yeah, I think so.
Okay, let's say it's 96. You'd get 96 options to choose from.
Check the math.
Yeah, somebody do the maths. You'll have, yeah, so I've written it here. So you'll have a smaller range of last words that match your key. So when you write, you know, what I said, 300 was gas and lend. You're looking at a total, you know, quite a lot of words that it potentially could be.
256.
Okay, awesome. But when you do 12, when you do 12 words, then the range of words that it could be is going to be smaller from this sheet. But the number of options you're going to get from like a cold card is going to be more. But either way, you're just doing a cross-reference and you're saying, right, it can only be between these words and these are my options. It has to be that word. And there will always only be one possible last word. So that's the end of my presentation. That is the last word of the presentation. Are there any questions though? Like, I'm sure that there was a lot to download there. Yeah.
How do you make sure that you didn't mess up it and then you load your wallet, you lose it, and then you try to regenerate it, and then you find out that something's wrong, and your wallet that you've regenerated goes to nowhere?
That's what the checksum is for, pretty much, isn't it?
Yeah, but the other thing you can do is test it. I think it's a good thing to test. So you look at you take your C words and you run it through, you do it again. You take your hex letters and you run it through the lookup table and you verify that you get the same answer every time. As long as you do that, if you do it 2 or 3 times, then you can be confident. But it is a bit tedious.
Yeah, you should definitely send like dust a small amount of bitcoins there a few times and make sure you can take them out and whatever. But the checksum solves exactly the problem you described. Yes, it does, because you wouldn't manage checksum if you mess it up. Oh, maybe I misunderstood.
You could. There's still things you can mess up throughout this process, right?
It's just you're gonna have 24 words from your KA,
Yeah.
and then you're gonna have a checksum that might change. Like the 24th word, if you're using it as backup, will be different as if you use it as a wallet also.
Right. So how is it gonna be different if you wrote it down with a checksum and everything, and you just wrote a proper backup and you decided which checksum is?
So if you use AD to generate the new seed,
Right.
you still generate. I'm confused.
Well, you just if you generated 2 original seeds, right, and you write down your 24th word with checksum, that's fine. The one that gets stored afterwards is just the resulting of storing the other 2, so you should be fine.
Yeah. Any other questions? Let me get a feel for the room. Do people think that this is something you could do at home? Raise your hand if you think you could do this at home.
So Dean,
Yeah.
I know you were said at the beginning of this talk. How do you attach this to an existing? Like you're saying about, is it for future things, or can you use it in an existing version?
Yeah, if you have an existing, you're saying like you have an existing seed.
Yes.
Yeah. So yeah, if you have a single seed right now and you want to not make it so brittle, so scary, you could use this worksheet. You would go backwards a little bit. So you would take a word and you would convert it into 3 hex characters per word.
I'll take my seed, my current seed.
Take your current seed and put it in A.
The English words you have. The English words you have.
Yeah.
Turn it into hex and then put it in the A section.
So you do reverse the steps, reverse.
Reverse the steps.
You look up. You start with the last lookup table, right?
Yes.
Because you have the English word. You have to get the hex.
Yeah.
Yeah.
Do it backwards, and that will give then do this.
Then you need 2 seeds. 2 seeds. You need 2 seeds.
So you'll need 2, but you'll get A. You'll fill in A, the whole of A with that. Then you need to do B. For B, you use the dice.
Okay.
And then,
another seed that you also have generated if you don't want to use the dice.
or yeah, you could generate another seed and do that backwards if you like. And then when you XOR them, you'll get your final set of words. So then what you do is you maybe don't throw away just yet until you've tested it a couple times. But ultimately, the idea is once you're happy and you confirm that the other 2 seeds, when you XOR together, will give you that first seed, the one that is your private key. Then you know that you've got these 2 pieces. You can throw away the original private key. And then that way, there's no evidence of it ever existing anywhere, except for maybe on your wallet.
So anytime you want to generate the original one, you use these 2 seeds to bring those 24 words back.
Exactly.
There's a trade-off, of course. Like
It is.
you get plausible deniability, but it's a headache, right? Depends if this is the right headache for you. For some, it definitely is.
And I think it's really, I think it's really good for inheritance. Like one of the things I've been thinking about is, so you would have, let's say you have your wallet on maybe a cold card, or maybe you just have it on Blue Wallet or something like that. And that's your day-to-day using wallet. Maybe you lose your phone, so you need a backup. Well, what you do is you keep one on the internet, one on a steel card or whatever, and that's your emergency backup, and you don't need to touch it unless you lose your phone or somebody steals your phone or something like that. So that's that. But then also, if you want to think about inheritance, then you create another set of 2 seed words that will come together and give you the same private key. You put one on maybe a steel plate, and you cover it, and you give it to a lawyer, and you say this person will inherit this piece of jewelry. Call it jewelry, call it whatever you want, when I pass away. And you give the person who's going to inherit the money the other 24 words, and as well as instructions, exactly what to do when they get that final piece. And so that's one thing I'm still going to work on. I'm going to probably create a PDF with like very clear instructions, and then I'm going to publish it, and I'm going to try to make...
I have a question. You talked about SeedXOR versus multisig. Do you have any thoughts on SeedXOR versus passphrase? As in, like, you use a different seed and passphrase. Maybe explain the passphrase for people who don't know what it is.
So,
and then I'll share your comments again.
So typically, the one way people suggest to create a little bit of security in your backups is have your 24 or 12 word seed backup, but then also add a passphrase. And that passphrase is there to make sure that if somebody were to find your seed, they still don't have access to your Bitcoins. But
This passphrase is like a password.
it's like a password.
So you can write anything. It can be anything.
Yeah.
Both. No?
Yeah, but it would make the instructions for inheritance a bit harder. But yes, you can. There was a tweet recently. What's his name? The big beard guy who does like mining. I forget his name. That's really bad. But he did a tweet the other day. He showed 4 seeds. He just put them out there, and he gave the fingerprint of his each of them. But he said, "I'm not giving you the passphrases. If you can crack this, then I'll give you can get the money that's in this multi-sig account." And all they had to do was use a password cracker, because passphrases typically are not very secure. They usually use a password like my password 1234. Even if you do something pretty secure, it's not as secure as seed words. And
Well, what if you have, but what if I use a password generator, which is gonna give me something that really has good entropy? I think that's safe because
it is, but then you lose that ability. The one thing that a passphrase is supposed to give you is this, like, oh, you can remember it, or oh, I can put it, handle it like my passwords.
I never had, personally, I never had this feeling that it's supposed to be easy to remember. I always had a feeling anything that's easy to remember is crackable, so not just be
Yeah.
easy. But I don't know, what do people think that?
I think just because it's called a passphrase, that somebody might think, oh yeah, let me make it something I remember. If there's even a chance that somebody's going to look at that and go, yeah, I'm going to do that, and they're going to make a bad decision. I think this is, you can't make a bad, well, you can if you don't use dice and generate proper entropy, but ultimately you're going to get 256 bits for every part. You don't need to worry, like, I don't need to worry that somebody's going to follow my instructions and then create a vulnerable wallet. That's basically the point. Like, what my goal when I was thinking about all of this was, how do I make a guide that somebody can follow that is idiot-proofish, like as idiot-proof as possible.
As far as entropy measure goes, because the trade-off comes with the complexity, right? So,
Yeah. But I think if you give like very clear step-by-step instructions, you can maybe get rid of a lot of the complexity. That's my.
You don't get rid of it. The complexity is still there. You may make it easier for people.
Yeah, you make it easier.
Disappear, right?
Yeah.
So it's very much like having a passphrase, except the passphrase is the whole 256 bits of another seed, and the added bonus of them both being viable on their own, so you can suddenly decoy stuff, whereas you can't use password 123.
Exactly. But technically it's different because you're not, you could, if you wanted to, take those 24 words and make it your passphrase. But then the way you combine them is different. Now you have to, so technically it's different, but in practice,
You can abstract and highlight one.
Yeah.
You're talking about Python scripts. Why didn't, I mean, here's the thing. If you do this, you're still gonna need a computer and you're gonna insert the words in a computer that's presumably secure. Why not have a Python script that helps you store the words directly? I mean, you write them in English and it stores them. I can't believe I didn't, or maybe that exists. Maybe that's something to be done.
Wait, so what was the question? Why don't you have a script?
Well, why not? Because no one did it, but I was trying to say that should be something that should be done.
But let's say the idea.
Sorry, a Python script.
Yeah.
Where I input the words in English, and then it results in them being stored. It does the storing in the background.
Oh, yeah, no, maybe this one doesn't do it, but the code card will do that.
Oh, really?
Yeah.
Oh, okay, cool.
And I've made a pull request for a feature, but I need to write some tests before it will get merged.
Yeah.
But it's a really cool feature where if you have a 24 words on your code card, you will be able to then XOR it, and you'll be able to save the output of that to a file on an SD card. And it'll be encrypted the same way that it encrypts a passphrase when you write it onto an SD card.
Which is another 12.
So now you can imagine that you've got this code card, it's a signing device. It's got a valid seed on it. If somebody were to figure out your PIN and get access to it, they can sign things with it, but maybe you don't have Bitcoin on that address. But you have this SD card. It's another factor. If you put them together and then you XOR them, then you get to your final wallet. So when you want to sign something, you take your code card, you go to where your SD card is, put it together, you XOR it, and then you sign. And it's a little bit, it's an extra step, but it's more secure and it's not that hard. Yeah.
Does the seed signer have the ability to XOR two keys?
I don't believe it does, but
That'd be nice.
Write it up, then I'm sure you have
I'm sure if you, yeah.
So and
It's
then you
Python.
just scan the two QRs and it will do it in the background, which is what you really want from a user experience point of view.
Yeah.
That would be a huge improvement indeed.
I've noticed that it's got. I haven't explored this device properly or for very much, but I've noticed it's got like 4 slots in memory where you can store seeds. So yeah, you could scan 2 or 3 and then go right now XOR it together. That would be a feature. There was a. Well, I'm done, so we can like stop recording now. But thank you.